Okay, so here we're going to make a power rail PCB, homemade. So we get your standard PCB sort of component prototype board, single-sided. We cover it with copper tape. Now I use slug tape. It's a lot cheaper than getting one that's designed especially for, or sold, especially for PCBs and doing stuff like this. But it's copper, does the same job. You know, as long as you've got more than 35 nanometers, it'll do the job. So now I just get my Sharpie, I start drawing a circuit on the top side so I know where to put my components. And this is done at double speed because I'm not the fastest in the world. But it's handy to know where you want to put your components before you start drawing your tracks out on the backside. I might even put some components on in a minute. I'll just keep watching. Have a look. If you haven't subscribed already, take this moment to subscribe, share, like, all that good stuff. It does get a bit more enthralling for all your electronics projects. But as you can see, I've now finished drawing. I'm going to put a connector in so that I can see where it is as a reference point on the back side. And then I'll just draw my legs. As you can see, I'm going to use a bus bar down one side of it. I've added some more components there so that I can get the right spacing, because obviously the physical layout is quite important. And then you just draw your copper terminals that are on the other side. Copper terminals, tracks I mean. And now you can see where the tracks need to be. Obviously I didn't make you suffer through all of that. Just get a, I don't know what the PC term is, but it's a Stanley knife. A craft knife maybe, I don't know. I'm not on any sort of commission here. Try not to puncture my fingers. So I've cut around the track and now I'm just scraping off the bit that I don't want with an electrical screwdriver or modelling screwdriver. Just a flat blade. It just peels off nicely. Try not to damage any of the other tracks that I want to keep. Obviously you have to watch out for those the solder rings. Make sure you haven't got any overlapping. Once I've finished scraping everything out and cutting everything out, that's kind of what it looks like. So it's quite nice. Now I use a standard prototype breadboard here because I'm putting the pins in and puncturing them through the copper so that I can put a buck converter. And of course, if you've ever soldered pins onto a prototype board, they are a nightmare to get straight. So a little tip is I put them in a breadboard so that they stay nice and vertical, solder them on. Try not to burn out any components. Soldering's not the best in the world, but it does the job, right? It conducts electricity. That's all we want. This is obviously for the Osprey model because the servos need quite a nice lovely little bit of current. So they have to, you can't run them from an Arduino or really from your receiver because it'll blow it up. So you put the power in through a separate power supply, which is what this circuit's for. Now a little bit of soldering on the underside, as if you haven't got enough of my bad soldering. If you can do it in one hit, that's much better. If you keep reheating it, you can get a dry joint. But unfortunately, something is better than nothing. Surprised I haven't burnt my camera out with my hands being so shaky. Now I've soldered all of the blocks in as well. So there you go. Saved you a bit of time there. You didn't need to see that. So here I'm going to do a quick resistance test across the tracks. And because they're all connected, I can just use the terminals on the screw blocks. So now I'm going to get a spurious resistance. That's normal when using a buck converter. because obviously you've got capacitors and everything. But if you're ever unsure, like me normally, just get another buck converter and see what the resistance is across it. Now we're coming to the end, in for the grand finale. We've got 12 point something volts there, and we've got 11 coming out. So we need to adjust the buck converter adjustment screw. So I've just put it in the output, and I'm just going to turn it anti-clockwise and turn it down to 5.02 volts. You don't want it too high, you blow stuff up, but if you put it too low or bang on, then it will just, when you put a massive load on, you'll get a voltage drop. Anyway, I don't want to waffle on for too much longer, so I hope that was helpful. Subscribe, like, share, and thank you very much for watching. Have a good day.